name. Okay? So just like what I said, it's up to you guys to check your understanding and try to do the blue example. Sige, sundugon ninyo kung unsa akong gibuhat so that you can try if you really learned something. Okay? You may take a screenshot of this or you may pause the video. Okay, now let's proceed with our next topic, which is simply connected to this. This is basically a 3D version of a sodium chloride, no? Kani sa table salt. This is the 3D of that version. So in this case, we have there the term lattice energy. So ano nga ba yung lattice energy? Basically, lattice energy is a quantitative measure of the stability of any ionic solid in its lattice energy, defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous ions. So, from the statement na kabalo na mo nga, one of the characteristics di ay of ionic compounds, they are solid, no? So, in this case, remember that at 180 m and 25 degrees Celsius, all ionic compounds are solids, no? So, unsa kay ito? Lattice energy is the energy required to separate 1 mole of ionic compound into gaseous ions. Okay, another. Each cation in a solid is surrounded by a specific number of anions and vice versa. So, ibig sabihin, it's not a simple Na and Cl anymore. Why? Because you have a lot of NAs, a lot of chlorines, no? So, they interact with each other. They are not just interacting chlorine and sodium lang, no. They also interact with another chlorine, another sodium, and so on and so forth. That's why the overall stability of a solid ionic compound depends on the interaction of all of these ions and not just merely on the interaction of a single cation and single anion. Dili lang siya nag-interact sa isa lang ka chlorine o isa lang ka sodium. No. Nag-interact po siya sa other chlorines and other sodiums. That's why lattice energy is very important. Ang problema, most of the books, they don't have a concrete explanation or a concrete way of trying to solve the lattice energy. But in this case, we have here two ways on trying to check the lattice energies of these ionic compounds, no? That's according to Raymond Chung. First is using the idea of the Coulomb's law. Very simple. This is the interaction of the first example nito is lithium fluoride, no? So there is the charge of the lithium multiplied by the charge of the fluorine, which is negative, divided by the radius. When we say radius, it simply means the distance between the radii, the nucleus, the nuclei of these two ions, no? Mao na siya ang buot pasabot. So we can use the concept of the Coulomb's law here, and then in this case the other one is we have a more complex one which is called the Born-Haber cycle, which relates the lattice energies of ionic compounds to ionization energies, electron affinities, and other atomic and molecular properties. Okay. So let's let's apply muna the Coulomb's law. Okay? So I have here predict which of the two ionic compounds has higher lattice energy using the concepts of the Coulomb's law muna. So the Coulomb's law, remember, this is how Coulomb's law works. So in this case, we have simply multiply the charges of the two ions divided by the radius, which is basically the distance between their their nuclei. And then let's start with sodium chloride versus lithium chloride. So how do we use the concept of Coulomb's law in predicting which of these two ionic compounds ang mas taas og latest energy? Okay, so dinhi ata, no? Unsa nato ni siya? Let's try muna to check the sodium chloride. Okay, so I have here the periodic table, no? Oh, yun. So when we try to open the periodic table, sodium is in group 1A. Okay? So sodium is na siya sa group 1A. So it has it has the ability to give off one electron. So na siya charge. Pila yung charge? Positive 1. Very good. So in this case, you have Na. Oh, you have Na na siya 1 plus. Okay. Sunod, chlorine. Chlorine belongs to group 7A. So, it has the, kulang siya ng isa para mahimong 8. So, it has the ability to accept one more electron. So, in that case, ang yapong charge is positive 1. So, in this case, we have Cl, 1 negative. Okay? So, if we try to check the radius or the distance between the two. So in this case, assuming this is simply R, no? Versus lithium chloride. Okay, punta tayo kay lithium. Si lithium is found in group 1A also. O, nasa sa group 1A, o. Okay, lithium. So, it has a charge of Li 1 plus kasi it has the ability to give off or to donate 1 electron. Punta tayo kay chlorine. Si chlorine is 1 electron also, no? So 1 electron. Okay. Ang ma-accommodate niya. So it has a charge of this one. Now, when you multiply the charges of sodium and chlorine, that will still result to 1. When you multiply the charge of lithium and chlorine, sodium and chlorine, parehara sila 1. So asa man sila magdepende? Asa man sila magligas? They will only what? In your radius. So ibig sabihin, again I will repeat, radius is basically the distance between the nuclei of sodium and chlorine and the distance between the nuclei of lithium and chlorine. Ang problema, which of the two man ang ato ang concern ani? So you simply go back to your discussion on the atomic radius. Okay. Now in this case, between sodium kasi the chlorine is constant raman na, no? So assuming ha mao ni ang chlorine. So this is the atomic radius of chlorine. So which of the two man ang pinakagamay? Is it the sodium or the lithium? Okay, let's go back to the periodic table. Sige, between sodium and lithium, ayon. You go to your topic about periodic trends. Okay. Sodium and lithium. Kinsa man ang mas gamay sa ilaha? Ilang atomic radius. Okay, so kinsa man? So in this case, when we try to check the kasi constant man ang chlorine, no? So in that case, lithium and sodium. Sodium is slightly larger than lithium. So we can write it as if allow me to use green. Sige, green. So if this is sodium, sodium is larger. So assuming lang ha na ganito. Ayun. So this is sodium and then your lithium is slightly, so mas gamay siya. Tama ba? Makita ba? O basta, mas gamay ang or smaller ang imuhang lithium. So in this case, if we try to check the definition of the radius that we're talking all about, it's the distance between their nuclei. So dako ang chlorine, dako pod ang sodium, so they will have a larger R. No? So allow me to write a larger R here. Between the lithium and chlorine, mas duol siya nga naman. Because the atomic radius of lithium is smaller man compared sa sodium. So allow me to put here a smaller R. A smaller R. Karon, ang pangutana, which of the two man will have a higher value if we're going to divide that? Of course, it will be the lithium chloride. Nga naman, if we try to, sige ha, atong itry og solve. So, if we multiply this, 1 times 1, that's simply 1. And then we divide it by a larger R. No? Compare it to this one, this is simply 1 gihapon. Pero we divide it by a smaller R, smaller value of R. So this lithium chloride will result to a higher value. So in this case, we predict that the lithium chloride will have higher lattice energy compared to the sodium chloride. Again, we are using, no? We are using the concept of Coulomb's law, no? Pero ang problema lang ani, we cannot determine the exact value kasi we're simply predicting, no? Predicting naman siya. So the answer there is lithium chloride. So NaCl is, it has only, when we try to check na the real value according to, I'm using the chemistry by Raymond Chang 10th edition. So the sodium chloride has a 788 kilojoules per mole na lattice energy, and then the unit is kilojoules per mole because it's the amount of energy. Again, I will repeat, lattice energy refers to the amount of energy required to separate 1 mole of that compound into gaseous state. And then for lithium chloride, it has a lattice energy of 828 kilojoules per mole. So tama ang ato ang prediction using the Coulomb's law. Okay? So again, we are simply predicting, no? So I hope you understand that. Okay. So I hope you can also try to compare different compounds. Katong examples na to a while ago, you can try their comparing them, no, in the previous slides para mahibawan nato if you can predict which is or which has the higher lattice energy. Okay.